Hi, Pär.
Hey, Peter.
Yeah. Welcome to the podcast on everyday metallurgy. We're going to talk about mining of rare earth in Europe today. So could you give a short introduction to yourself and where you work?
Yes, my name is Pär Jonsén. I am the CTO of LKAB Business Area Special Products, also heading all development that is non-ferrous, meaning that we're looking for new minerals, new metals, new processes to actually expand our operations from our mines and out to the global world. I have a background as a professor in solid mechanics at Luleå University of Technology in Sweden, and have actually changed to LKA within the last 2 years.
Yeah. Yeah, we met when you were a professor, so it's quite a jump to take to go into such a rough industry as mining. You're working at the Kiruna mine. Could you give a little story about the mine, where it's positioned, the size of it, to give some insight in what volumes we're talking about?
Actually, I'm heading all the mines from my perspective from the business area. So we have actually 3 mines. We have Kiruna, which is the world's largest underground iron ore mine. Then we have a mine in Gällivare, the second largest, and then we have a Svappavaara, which is an open pit mine. And all these quite large operations. We are a very old company, started in 1890 with operations outside Gällivare, and that we have been focusing actually, and the largest product we have is iron ore and iron ore pellets. But now, as we come into this green transition that all companies go through right now, we need to change a little bit how we use fossil energy and so on, but also take care of the waste that comes from our mines, actually. And there we see a lot of opportunities to have new products on the market. But of course, we also see the challenges in Europe to get these markets out to everyone.
Yeah. So the latest findings, as I understanding in the mine, is an ore that is pretty high in rare earth elements like neodymium. Can you disclose a little about the volumes and the percentage of that ore of rare earth?
Yeah, I can tell you a little bit about the background, because we were 5-6 years ago, we started to look into the waste that we produce from the mine, and we could see that we have a part of it is phosphor, and we have a mineral called apatite in the waste. And when we started to look into that for all the mines that we have, we could see that we have rare earth element in this mineral called apatite. So we started to work on how to process it, how to get it out, and so on. And then some years ago, we saw that we have this in Kiruna. It's a big mining area, and we have focused all the resources in what we call Kirunavaara mine. It's the biggest one. But we have to go deeper and deeper in that one every time. But then we started to look around the mine, and then we have an old deposit that was found in beginning of 1900. And we had operation in that area until 87, a small scale.
Okay.
And the thing with this deposit that was very high in phosphorus. So it was quite tricky to sell that kind of ore. And also we have very good and pure magnetite in Kirunavaara. So we were focusing more on that one. But nowadays, we see that this phosphorus, the high phosphorus content, come from the apatite that's in this Pr mine. And when you start investigating that phosphorus and apatite, we could see it's a crystal structure on that one. And inside apatite, there were attached a lot of REEs, rare earth elements, actually. So that was interesting. So then we started to look in what is the potential and so on, and now it have evolved more and more the last years.
Okay, and now in Europe there are a lot of activities in advanced materials, bringing production home, but I also understood that I think it's 3% of the raw materials that are used in Europe are manufactured in Europe, but Europe is responsible for consumption of 30% of the world raw material. So this Advanced Material Act that Europe are implementing is supposed to bring home, and what does that mean to a company like LKAB? And is it just words? Are there any funding? Do they bring companies together, or what happens within Europe on this perspective?
I think we are on a big change, as you say, and it's very. We only have 3% production, and we need 30. And of course, it's a global society that we live in, so we need to import, of course, and also export. But we need to be more self-sufficient. And if you look at iron ore, we are quite self-sufficient. But if you look at other minerals and other materials like this rare earth element, the Chinese are, of course, the most dominant one in the world. And if you look at permanent magnets, which I think Europe has started to wake up a little bit with the CRMA Act, Critical Raw Material Act. I think that's a very important step. But it's in the beginning. Now we can actually apply for having this type of project, and we have that. We have applied for 3 projects now within that, to have a faster way through the authorities to get the permissions, because that is something that is very difficult for us to get environmental permission for our operations. So on, that we put a lot of effort into that.
Yeah.
But I think we have a good chance. But it's also about the value chain, because as the Chinese are selling these magnets directly to us that we need for generators and electric engines and so on, we haven't built up that in Europe yet, and we can provide, I think, most of European needs in the future, not right now, but in the coming years, if we can develop our operations, we could, instead of just putting out on these deposit dams that we have for the waste, we can actually take care of that material, process it, and so on. But we can only do a part of the value chain. We can go all the way to separation. But if you look at magnets in general in Europe, there's a few that actually can produce magnets in Europe. And I think that's a huge problem. And why are these rare earths so important? Of course, if you could blend in 30% of neodymium, for example, in a magnet, you increase the strength 9 times, meaning that you also can have a size down how big the magnet is. And of course, that's very good for getting down the weight on electrical vehicles, but also generators for wind power mills. So I think we need to collaborate more inside Europe, and also we are seeking companies to work with. If you go down the line in this value chain, I think we see that we need that happen actually to be self-sufficient. It's not just enough to produce the concentrate. Someone has to take it to a product.
Yeah. So when you say concentrate, is it concentrated oxide ore?
Yeah, we can go all the way to the oxides. We have a company in Norway now that has a very interesting technique. It's called REEtech. It's a startup, but they are in operations probably next year, and they can actually separate our concentrate to an oxide form.
Okay. And then to refine the oxides into a metal, as I understand, that is the area where you need chemicals. You need a lot of water. The so-called polluting step. That is what we're lacking in Europe.
Exactly, the knowledge of that one, but also the industrial capacity is not there. So we need to do it environmentally friendly, and there are techniques that you can do it in the lab, environmentally friendly. And REEtech is, I think they have some ideas around this, but to take it to this in industry has not been done yet. So of course we need to put resources on research, but also for industrial implementation. That's very important. But also for making the magnets in the end. I think it's very few magnets that are really made in Europe today. So we need smelter techniques and so on to be developed in a good way. So.
Yeah, because when you have the metals, you need to make the alloys, and then you need to atomize it to make it into powders.
Yeah.
You need to compact the powder and sinter it. So there are a lot of steps, and only very few companies available of doing it.
Yeah.
And absolutely, there's this lack in between the mine and the oxides and the metal.
It is, it is. And we haven't worked really that way before. Also in LKAB and these mining companies, I think it's been quite separated. But I think if we're going to have this value chain inside Europe, we need to collaborate much more.
What about funding? You said that the European Act could help getting the allowance from the authorities, but it also takes a lot of money to start up this. So will the European community come with funding, or is it only words again?
Yeah, we haven't seen any funding yet, usually when we starting with this big project, we put the funding there ourselves. But of course, I think also for technology development downstreams, I think it's highly important that to solve all these production steps and to all these challenges ahead, we need funding for that, also for SMEs and companies that want to go into this. I think it's very, very crucial. We are mining and so on, we can do that. Of course, there's a lot of investment in infrastructure in a mine to do that. But I think the critical part, it may be also the technology part downstreams, how to do that in a good and environmentally friendly way.
Are there any companies in Europe that could be a candidate for it? Because it's not only money, it's also competences. So are there anybody who already works with process similar to this?
They're all mostly researchers, that a very few amount of people in this area. And actually, if you look at where all the competences, it's not in Europe, it's in China, most of it. They have developed this for 30, 40 years. They have put a lot of effort into this, and they are outstanding actually right now. But I think we have all the chances in the world to come back in this area, and we have similar competences, similar companies working with powder metallurgy and this. So we need to build it up a little bit from the beginning again.
So when we are going to build up from start. When do you think a production setup will be ready in Europe?
It's a good question actually, but it will take some years. It's not easy, and also to be build up the competence, but also to build up the industry. It takes a while. We don't have this infrastructure, but a good guess, within 5 years, we could probably have something, and then starting from there, develop and grow.
Yeah. And if we look at, and I think we need to look at prices, the expected prices. How do you see competition price-wise against the Chinese magnets?
Yeah, it's a difficult task. They do it quite cheap, and but we need also to have this self-sufficiency, especially for this critical materials. It's also one part of it is military equipment, for example. When we talk about optics and radars and also very strong magnets that can sustain cold conditions for air fighters and so on. So in some we need to have some production at least. So it's a journey, and price-wise, as you say, probably we can press the price quite much, especially if we can do it environmentally friendly. We can have that as a premium or something, that we can do it more carbon neutral and so on, because I think we have these possibilities actually to do it more environmentally friendly.
This way of working in a mine, extracting the iron and then of the long tail, you pick out the remainings. So you reduce the scrap or the landfilling. Are there other elements in the long tail that could be extracted? You said phosphorus.
Yes,
there's also a need of phosphorus.
Yeah, there's a huge need of phosphorus, especially right now with the war in Ukraine, because Russia has been a large producer of phosphorus fertilizers to Europe. So actually that's a very important part of phosphorus. If you can have multiple products coming out from this tailing part, it's really good to have a good business case. And also one good thing with us that we're working with the waste stream or the tailing is that we don't have to open up a mine specifically for rare earth elements, because we will take out this material anyhow for iron ore production. So we don't have to do mining operations ourselves for that. So we only use the waste. And that in that sense it's a very cheap product from the mine. But of course the processing, when we want to have pure products and so on, the price goes up. But so that's an advantage for us.
I heard, I don't know if it's just a fun story, but somebody are talking about microbic mining, that you can use microbes to extract specific elements. Is that something you are aware of, and it's something you believe in?
We are aware of it, and it has been proven, I think, in lab scale. The problem I see is to do it in a very large scale. I haven't really seen proof for that you can do large operations and make it work in that sense. But we're looking into all new things that comes and see. I think there's a lot of potential in it, but we need to be able to scale it up. That's the issue.
Could it also be a way of extracting rare earth elements?
Yes, I've seen some reports around that it could be possible to do it that way. But it's right now I only see research result, not industrial concepts that would work.
Yeah. Then I would like to turn a little into the ore and the purity. Today in steel production, there's a lot of discussion about changing from blast furnaces using a lot of coal and going to DRI, direct reduction iron processes. But there are some demands for the ore quality to be able to transfer from blast furnace to DRI. How do you see LKAB products fit into DRI future?
It will work. It works actually. We have proven that in the hybrid project that our type of very pure iron ore, we have a really high grade from the mine, and with the type of production that we have for this DRI, as you're mentioning, it's very suitable for arc furnace production and also for direct reduction. It's been proven to be a really good steel in that sense. But of course, the debate is also in Sweden around electricity and energy, and that is something that we're working on to get it into a large scale. So.
Yeah, because the amount of electricity is so high that I think I read that 20% of the Swedish electricity will be used for DRI in near future. And that's only a drop in the ocean.
Yeah, it's quite a lot, and actually that's something that we put a lot of effort into solving and how to solve it, and yeah, it's a new technology, and when you start with new technologies, you have a developing path to stabilize it and to optimize it and reduce energy cost and so on. As long as it's a journey for us also, this part, but the test shows that it's a very good product actually in the end. But of course there's the problem as we mentioned with energy and so on.
Yeah. It's always Pär, I have a last question on back to the rare earth again. I remember that there was also somebody looking at a mine in Kvanefjeld in Greenland.
Yes. Yeah.
And they said that this field, if it was initiated as a mine, it could fulfill the world demand of rare earth for more than 1,000 years.
Yeah.
Do you also have a similar number of the ore and the availability of rare earth in northern Sweden?
I think in this Pr Jonsén mine that we're just outside our current operations in Kiruna mine, it contains the latest numbers as I was presented is 1.7 million tons of rare earth oxides. Is what I heard anyway. But we are drilling, we are investigating. I think we have investigated maybe 40% of this deposit. So, and it grows constantly. So I don't know where we will end up. But it's a very large deposit. If we get operations as we wanted, we can probably. I think I don't really remember how much, but it's a big part of Europeans' need at least for rare earth for many years. So,
yeah.
But I think I think to solve this problem, we need to look into everything. Also, recycling of magnets and so on. I think that's also an important part. If we could recycle it and have a good quality of the neodymium and praseodymium, that I think that's very highly important. But also look into other mine sites and look what type of waste do they have? Do they have this apatite or monazite that are carrying REEs? But altogether, I think we can do it in Europe. But We need to start developing all these technologies and collaborate all over Europe to solve it.
Yeah. So the mines in China where they extract the rare earth, is that also the long tail principle? So the core product is iron ore, and then there's some leftovers that are apatite rare earth containing.
As I understood it, and there's not too much information around this, but they have similar operations as us with the iron ore production, and they take care of the tailing. But also I think they have direct, they have some mines with really high grade, so they can do operations. Because if the grade is really high, you can then do all the investment in the mine infrastructure and so on, and make it a successful operation. And one of the things I think in Greenland, I don't know too much about it, but to put in all this infrastructure and all the operations and have the competence to run a big operation mine, it takes a lot of effort and it's very costly. So that could be maybe something to, if we're really in a need to have this rare earth, we should solve how to do that investment in a good way.
Yeah. So let's cross our fingers that investment will come soon.
Exactly.
At least I'm going to discuss this on a meeting of the 2nd of October in the European metal powder industry in a group of people working with functional materials, and magnetic materials are absolutely functional and important for our industry. So I will try to help initiate some activities so we can boost and hopefully in 5 years have our own manufacturing of not only magnets but also the raw materials that go into the magnets.
Yeah. Thank you very much, Peter, and I hope you succeed with that, and we can keep contact.
Yes, thank you, and thank you for sharing your information.
Yeah, you're welcome. Thank you.
See you.